Hi teachers, parents, and students. Welcome to TeachKind Thursdays. I'm Samantha, Manager of Science Education at PETA, and this is my daughter Elliot.
If you haven't been following along with our lessons each week, you can always catch up on TeachKind's social media pages.
TeachKind is PETA's Humane Education Division, and we have a whole team of educators. I've been an adjunct professor of biology for over a decade and have a master's degree in biology. Before coming to PETA, I worked in a biotech startup cell laboratory.
The TeachKind team creates amazing online content, lessons, and other materials, all of which are free. So be sure to check them out at teachkind.org for all your distance education needs.
Awesome. Today we have a special treat for you. Before we begin, make sure that you download and print, if you'd like, the worksheets at PETA.org/SynFrog. There are 4 worksheets. The PreLab can be completed either before the dissection, but no worries if you weren't able to do that. You can always use it afterwards to reinforce the concepts. The dissection lab and answer sheet may also be used during the lab or afterwards as well. During our lesson today, we're going to discuss everything you need to know to complete the fast facts and comparative anatomy worksheets. So be sure to have at least those 2 handy.
Let's dive right in.
Let's do. Did you know that animal dissection is archaic and hasn't changed in a century? Can you imagine if we were still watching silent black and white films, riding around in a Model T, or using an abacus? There may have been a time when we didn't know much about the internal anatomy of frogs, but that time has long passed. Animals are not ours to dissect. Unless, of course, we're talking about a synthetic animal.
Did you know that many animals who are dissected are actually killed on purpose? They are sold by biological supply companies that are not in the business of protecting animals from pain and suffering. Their business remains unaffected regardless of how poorly the animals are treated.
It's awful. Did you know that there is no curricular requirement to dissect animals at all? In fact, modern curricula, including International Baccalaureate and the Next Generation Science Standards, make no mention of it. Medical schools are also innovative, and they do not use any animals to teach medical students. Experience with dissection is not expected nor required of incoming students. How's that for good news?
Did you know that some students are turned off from pursuing careers in science because they were forced to dissect animals? Studies show that animal dissection is not an effective way to teach basic and advanced biological concepts, and that some students, like myself, may feel upset or afraid when asked to cut apart an animal.
That's right. Now that we know why we shouldn't dissect real animals, let's dive into today's science lesson. Today we're going to learn about the external and internal anatomy of a frog, including classification, organs, organ systems, and comparative anatomy.
This is SynFrog, which was developed with support from PETA by the company SynDapper, the world's leading manufacturer of hyper-realistic synthetic human and animal surgical trainers. It mimics living tissue and is an anatomically accurate dissectable frog model.
Woo, that is a mouthful, and it is an amazing, amazing model. Frogs are classified as amphibians, which means they spend a portion of their lives in water and a portion of their lives on land. Amphi means both, and bios means life, so they have 2 lives. Frogs begin as fertilized eggs in water, and then they develop into tadpoles, which are fully aquatic, and then finally they become either aquatic or terrestrial adults. They undergo metamorphosis, which is completely changing their body from one form to another. They're ectothermic, which means that their body temperature depends on the external environment or the temperature outside of their bodies. The SynFrog models a leopard frog whose scientific name is Lithobates pipiens. To easily identify anatomical landmarks, doctors and veterinarians use directional terms.
Dorsal and ventral are opposites. The dorsal side is the back. Think of a dorsal fin on a dolphin, for example. The ventral side is the belly. Superior and inferior are also opposites. Superior refers to the area nearest the head or cranium, and inferior refers to the area nearest the caudal or tail. Medial and lateral are opposites. Medial means near the midline of the body, or the imaginary line that would cut your body into equal right and left halves. And lateral means away from the midline.
Such as the toes. Very nice. So does our frog, does the dorsal and medial sides, do they differ in color?
Yes, they do.
Yes, they do. Excellent. And how many toes are on the hind legs?
5.
And are they webbed?
Yes.
Awesome. And how about the front legs?
4.
Awesome. Now check out the skin. You may be able to see that our frog is wet and slimy. Frogs have very thin skin that enables them to exchange gases or breathe. This is known as cutaneous respiration. Let's check out the frog's head and mouth. Can you find the tympanic membrane? Very nice. And what do you think that's used for?
Hearing.
That's right, the tympanic membrane is used for hearing. And let's also find the external nares and the internal nares.
Ooh.
Very nice. So now we're going to do the dissection, which is I think what everybody's most excited to see.
Yes.
We're going to identify all the organs internally and also pull them out and take a look. So we're pinning the frog.
Mm-hmm.
So the ventral or dorsal side is up.
The ventral.
That's right. We're looking at the ventral side, which is the belly. And we placed 4 pins in his or her legs. Well, she's really an it because she's a synthetic frog.
Yeah, but if she were real, then she wouldn't be in it.
That's right. That's right.
Oh, she squirted.
Ooh, very realistic. Very nice. So we are, so Elliot is doing a cut down the midline, and then she's going to open up the body cavity so we can, ooh, very, very wet.
Yes.
Very juicy, this model. Okay, great. So we've got the midline opened. We're going to use some additional pins to pin back the skin and muscle flaps of the SynFrog. There you go. Excellent. So initially we can see a few organs. Let's see which organs we can identify.
Okay, we can see the liver right here, right?
Oh yes, the liver has multiple lobes.
Yeah. I think there's a third one over here.
Oh, there we go.
Yep.
Nice.
And the heart.
Excellent. And the small intestines?
Yes, small intestines.
Excellent. So we can go ahead and start excising those organs.
Here are the livers, the liver lobes. And then small intestines.
Yeah, so the small intestines are coiled and they're actually connected with connective tissue, which is the same thing that you'd see in a human body.
The large intestine. Ooh.
Oh, very nice. So that's the large intestine.
Yeah, and then this
small intestine.
Is this the stomach?
That's right. That's the stomach all the way up to the esophagus. Is that the tip top? Very nice.
And then these are the ovaries because you can see the speckled eggs in there.
Yes, perfect. So the oviducts and the eggs are the black and white speckles, if you can see that.
And then the lungs.
Oh, very nice. So they have paired lungs, just like humans do.
And in the back, the heart's connected to the kidneys over there.
Oh, nice. So we do see some vasculature. We see the heart, and we see the
Yeah.
paired kidneys as well.
And then the
Very
bladder.
nice. Oh, can't forget the bladder. Very nice. Very nice.
Yep.
Awesome. Did you notice anything interesting about the SynFrog?
Yes, it is a female, so there are no male reproductive organs.
That's right. Now let's check out what is similar and what's different between amphibians, like leopard frogs, and mammals like us. We both have tongues, but frog tongues are attached at the front of their mouth, whereas ours are attached at the back.
Amphibians and mammals both have a digestive and excretory system. Mammals excrete solid and liquid waste separately, whereas amphibians excrete in one single location, the cloaca.
Mammals and amphibians both have respiratory systems because we all need oxygen to live and a way to release carbon dioxide waste out of our bodies. Mammals have a diaphragm muscle that forces air into and out of our lungs. Amphibians breathe in through their nostrils and inflate sacs in their throats. Then they force the air down into their lungs with their mouths. Frogs are also able to exchange gases underwater through a process called cutaneous respiration or skin breathing. Mammalian hearts have 4 chambers, so oxygenated and deoxygenated blood never mix. Whereas amphibians only have 3 heart chambers, so blood is mixed, but that's really no problem because they can also exchange gases through their skin.
And how about the nervous system? Amphibians and mammals share special senses such as vision, smell, and taste, and can all feel pain and avoid painful stimuli. They have the same areas of the brain such as the cerebellum and the medulla oblongata. Most amphibians with legs have 5 toes on their rear legs and 4 on their front feet. Interestingly,
That is interesting.
their ulna and radius are fused, as is their tibia and fibula. Mammals have separate bones.
Wow. Animals are amazing. Frogs in particular are excellent bioindicators, which means they provide information about the conditions of their environment because they spend time both on land and in water. They're also able to withstand extreme environmental stress through a process that is called estivation, which is like hibernation.
Frog populations are declining in part to their use for classroom dissection, so we should do our part to make sure we never dissect them, never steal them from their homes, and never use them in classroom biology experiments.
That's right. Teachers, if you're interested in replacing animal dissections at your school and would like to get a SynFrog for distance learning or to make a video of your own, please email us at info@teachkind.org.
Thanks for tuning in.